Gay Lussac's law. This is a pressure temperature relationship and this was given by Joseph Gay Lussac. Joseph Gay Lussac. So this law is also called as Gay Lussac's law. Okay. And this law states that at constant volume, the pressure of a fixed mass of a gas is directly proportional to the Kelvin temperature. So, it states that at constant volume, the pressure of a fixed mass of a gas is directly proportional to the Kelvin temperature. Okay. So, mathematically we can express this as P is proportional to T, or we can write P by T will be a constant. The constant is K3. Okay. Now, if P1 is the pressure of certain gas at T1 temperature, P1 is the pressure at T1 temperature and P2 is the pressure of the same gas at T2 temperature, then P1 by T1 is equal to P2 by T2. So, this relation can be used to solve problems. Okay. Next, graphical representation of Gay Lussac's law. P versus temperature. Temperature is in Kelvin and pressure is in bar. Okay, at constant V1 volume, one curve is obtained, then V2, V3, V4. At different constant volumes, different curves are obtained. So, these are plotted at constant volume. So, these graphs are also called as isocourse. Okay, so these are the curves. When we are extrapolating it, they will meet at the origin O. Okay, and we can also see that V1 is less than V2, which is less than V3 and which is less than V4. Okay. Application of Gay Lussac's law. Application. Pressure of inflated tires of automobiles is constant. Okay. Pressure of inflated tires in automobiles is found to be constant. Okay. But in summer or on hot sunny day, when temperature is high, the pressure inside will increases, because as the temperature increases, pressure increases and the tires will burst. Okay. So, in a hot sunny day, in summer, in a hot sunny day, temperature is high. So, what happens? Pressure inside will increases. Pressure inside the tire increases and it will burst. Okay. But in winter what happens? Temperature is low. Okay. Temperature decreases. So, pressure inside the tire will also decreases. Okay. Pressure inside tire decreases. Avogadro law. This is a volume amount relationship. Volume amount relationship. And this was proposed by Avogadro, so it is called as Avogadro law. And this law states that equal volume of all gases under similar condition of temperature and pressure contain equal volume of molecules. Okay, this law states that equal volume of all gases at similar condition of temperature and pressure. Temperature and pressure contain equal number of molecules. Okay, equal number of molecules. Now, that is, volume of a gas is directly proportional to the number of molecules, and number of molecules is directly proportional to number of moles. Okay, is directly proportional to number of moles. Number of moles. And number of moles can be denoted as small letter n. Okay, so this law will be V is proportional to n. N indicates the number of moles at constant temperature and pressure. Okay. So this is called as Avogadro law. Okay, so we can write V is equal to some K4 constant into N, or V by N will be a constant. Okay, so if V1 is the volume at N1 number of moles and V2 is the volume at N2 number of moles, then we can write V1 by N1 is equal to V2 by N2. Okay, using this relation we can solve the problems. Number of molecules in 1 mole of a gas is number of molecules in 1 mole of gas is 6.023 into 10 raised to 23. This is called as Avogadro constant. Okay. Now, at STP, STP means standard temperature and pressure. At STP, the standard temperature is freezing point, that is 273.15 Kelvin, and pressure is 10 raised to 5 Pascal. Okay, or we can say 1 bar. So, at STP, 1 mole of a gas will have same volume. Okay, 1 mole of a gas have same volume, and in the case of an ideal gas, the molar volume at STP is 22.7108 liter moles. Okay, 22.71098 liter moles. This much will be the molar volume of an ideal gas at STP. Okay, and from this Avogadro law, we know V is equal to some K4 into N. This is a constant into N. And we know N is equal to given mass by molar mass. By substituting, V is equal to K4 into M by N. Okay. And we know from this molar mass will be equal to K4 into M by volume. And this M by volume is the density. That is, density is mass by volume. So, instead of M by V, we can write D. So, M is proportional to, that is, molar mass of a gas is directly proportional to the density of the gas. Okay, this is another relation.